sweet angels. Welcome to our new learning episode. I am teacher Nancy B. Pineda, your teacher for grade 8 mathematics.
We are now on the quarter 4 week 5 lesson in Math 8. In this learning episode, we will determine the conditions under which lines and segments are parallel or perpendicular. There are conditions that guarantee parallelism and perpendicularity. We have already discussed the parallel lines cut by a transversal on our previous episode. We see parallel lines everywhere. Lines on a pad paper, railways, edges of a door or window, fence that suggest parallel lines. On our previous episode, we have learned the initial ideas on naming angle pairs formed by two lines cut by a transversal. What you will learn in this episode involves integrating the key concepts of parallelism and perpendicularity of lines. Your goal in this episode is to learn and understand the key concepts of measurement of angles formed by parallel lines cut by a transversal and the basic concepts about perpendicularity. Let us recall that parallel lines are coplanar lines that do not intersect. In our illustration, we have the two lines, line L and line M. Again, these two marks means is parallel to. So in symbols, we can write L is parallel to M. For the second illustration, we have line AB is parallel to line CD. And a transversal is defined as a line that intersects two or more lines at different points. We also learned on our previous episode that when two parallel lines are cut by a transversal, they form 8 angles. The angles formed by the transversal with the two other lines are called the exterior angles and the interior angles. We also have the pairs of angles formed by the transversal with the other two lines. These are the corresponding angles, the alternate interior angles, the alternate exterior angles, the interior angles on the same side of the transversal, and the exterior angles on the same side of the transversal. And we also discussed that if two lines are cut by a transversal, then the two lines are parallel if the corresponding angles are congruent, the alternate interior angles are congruent, the alternate exterior angles are congruent, the interior angles on the same side of the transversal are supplementary, and the exterior angles on the same side of the transversal are also supplementary. To strengthen your knowledge regarding the different angles formed by parallel lines cut by a transversal line and how they are related with one another, you may visit the quarter 4, week 4 episode on this channel. Let us proceed to the postulates and theorems that are used to identify if the given lines are parallel. We have the converse of the corresponding angles postulate. It states that if two lines are intersected by a transversal and the corresponding angles are congruent, then the lines are parallel. The next theorem is the converse of the alternate interior angles. If two lines are intersected by a transversal and the alternate interior angles are congruent, then the lines are parallel. Next, we have the converse of the alternate exterior angles theorem. If two lines are intersected by a transversal and the alternate exterior angles are congruent, then the lines are parallel. Next, we have the converse of consecutive interior angles theorem, or linear pair. It states that if two lines are intersected by a transversal and the consecutive interior angles are supplementary, then the lines are parallel. Next, the converse of consecutive exterior angles theorem. These are the linear pairs outside the two parallel lines that are cut by a transversal. It states that if two lines are intersected by a transversal and the consecutive exterior angles are supplementary, then the lines are parallel. Next, we have the dual parallel theorem. It states that if two lines are both parallel to a third line, then the two lines are parallel. And lastly, we have the dual perpendicular theorem. The dual perpendicular theorem states that if two lines are both parallel to a third line, then the two lines are parallel. Later on, we will discuss further the perpendicular. Let's have an example. Let us use the given figure to answer items 1 to 6. For question number 1, if the measure of angle 3 is equal to 60 degrees, what is the measure of angle 6? To better understand this, let us mark angle 3 and angle 6. Since angle 3 and angle 6 are alternate interior angles, therefore, angle 3 is congruent to angle 6. Or, the measure of angle 6 is equal to the measure of angle 3, and it is given that the measure of angle 3 is equal to 60 degrees. Therefore, the measure of angle 6 is also equal to 60 degrees. Easy, right? Let us proceed to question number 2. If the measure of angle 3 is equal to 55 degrees, what is the measure of angle 5? Let us take a look at angle 3 and angle 5. What can you say about the relationship between angle 3 and angle 5? That is right. Angle 3 and angle 5 are same side interior angles. And since angle 3 and angle 5 are same side interior angles, therefore, angle 3 and angle 5 are supplementary. That means, when we add the measure of angle 3 plus the measure of angle 5, the result will be equal to 180 degrees. And we are asked to solve for the measure of angle 5. The measure of angle 3 is given, which is equal to 55 degrees. So we just have to substitute the measure of angle 3 into our equation. We have 55 degrees plus the measure of angle 5 is equal to 180 degrees. Next, we have to isolate the measure of angle 5. To do this, we have to subtract negative 55 on both sides of the equation, or we have to apply the addition property of equality. 55 minus 55 will be cancelled out, and 180 minus 55 is equal to 125. Therefore, the measure of angle 5 is equal to 125. To check if our answer is correct, we just have to substitute the measure of angle 5 into the equation. We have 55 plus 125 is equal to 180. So our answer is correct. Next, for question number 3, if the measure of angle 2 is equal to 50 degrees, what is the measure of angle 7? Again, let us take a look at angle 2 and angle 7. What do you think is the relationship between the angle pair 2 and angle 7? Again, you are right. Angle 2 and angle 7 are same side exterior angles. And same side exterior angles are supplementary. Therefore, angle 2 and angle angle 7 are supplementary. Again, supplementary angles are angles whose sum is equal to 180 degrees. So when we add the measure of angle 2 plus the measure of angle 7, just like what we did in question number 2, the result will still be 180 degrees. So given the measure of angle 2, which is 50 degrees, we just have to substitute it into our equation. We have 50 plus the measure of angle 7 equals 180 degrees. Then isolate the measure of angle 7 by subtracting 50 on both sides of the equation. We have the measure of angle 7 equals 180 minus 50. And 180 minus 50 is equal to 130 degrees. Let us now move on to question number 4. If the measure of angle 1 is equal to 120 degrees, what is the measure of angle 6? Again, can you identify the relationship between angle 1 and angle 6? That is right. Angle 1 and angle 6 are corresponding angles. And we know that corresponding angles are congruent. Therefore, the measure of angle 1 is also equal to the measure of angle 6 since they are corresponding angles. Therefore, the measure of angle 6 is equal to 120 degrees. Next, for our example number 5, if the measure of angle 8 is equal to 110 degrees, what is the measure of angle 4? For this example, what is the relationship between angle 4 and angle 8? You're right. Angle 4 and angle 8 are corresponding angles. Therefore, angle 4 is congruent to angle 8. We are asked to solve for the measure of angle 4 given the measure of angle 8, which is equal to 110 degrees. And since the measure of angle 8 is equal to 110 degrees, therefore, the measure of angle 4 is also equal to 110 degrees. We are now down to our last example for this area. For example number 6, if the measure of angle 7 is 65 degrees, what is the measure of angle 1? Again, can you identify the relationship between angle 1 and angle 7? That's great! Angle 1 and angle 7 are alternate exterior angles, and alternate exterior angles are congruent. Therefore, the measure of angle 1 is also equal to 65 degrees. We now proceed to the second part. We have to state the postulate or theorem that justifies M is parallel to N, given the same figure. Given the following information, state the postulate or theorem that justifies M is parallel to N. For this part, it is just like working backwards. We have to state the postulate or theorem that justifies that the two lines are parallel given the following information. For example number 1, given that angle 2 is congruent to angle 5. Take a look at angle 2 and angle 5. What postulate or theorem that justifies angle 2 is congruent to angle 5? The postulate that justifies angle 2 is congruent to angle 5 is the converse of the corresponding angles postulate. Next, state the postulate or theorem that justifies that line M is parallel to line N given that angle 4 is congruent to angle 5. What is the postulate or theorem that justifies angle 4 is congruent to angle 5? That is right. It is the converse of the alternate interior angles. For example, number 3, state the postulate or theorem that justifies line M is parallel to line N given that angle 7 is congruent to angle 1. Since angle 1 and angle 7 are alternate exterior angles, therefore the postulate or theorem that justifies angle 7 is congruent to angle 1 is the converse of the alternate exterior angles theorem. And for number 4, state the postulate or theorem that justifies line M is parallel to line N, given that angle 4 and angle 6 are supplementary. Since it is given that angle 4 and angle 6 are supplementary, and angle 4 and angle 6 based on our illustration are consecutive interior angles or same-side interior angles, therefore the theorem that justifies this is the converse of the consecutive interior angles theorem. Now let us proceed to perpendicular lines. Perpendicular lines is defined as two lines that intersect to form right angles or angles with 90-degree measure. Again, two lines that intersect to form right angles are said to be perpendicular. This is not limited to lines only. Segments and rays can also be perpendicular. The small rectangular square drawn in the corner indicates right angle, whereas the inverted T is a symbol used to indicate perpendicularity of lines, as in line LM is perpendicular to line NO. Or, on our second figure, we have line J is perpendicular to line K. To prove that two lines are perpendicular, you must show that one of the following theorems is true. First, if two lines are perpendicular to each other, then they form four right angles. Second, if the angles in a linear pair are congruent, then the lines containing their sides are perpendicular. And third, if two angles are adjacent and complementary, the non-common sides are perpendicular. You may watch the video lesson using the given links on the comment section. These videos will explain how to construct a perpendicular line to a point and a perpendicular line through a point not on a line. Here are some important terms, postulates, and theorems on proving perpendicular lines. First, the perpendicular bisector or the segment bisector. It is defined as a line, a ray, or a segment that is perpendicular to the given segment at its midpoint. We also have the perpendicular postulate. It states that through a given point, there passes one and only one line perpendicular to the given line. The bisectors of the angles in a linear pair are perpendicular to each other. Next, we have the perpendicular bisector theorem. It states that any point on the perpendicular bisector of a segment is equidistant from endpoints of the segment. Next, the converse of the perpendicular bisector. It states that any point equidistant from the endpoints of a segment lies on the perpendicular bisector of the segment. And lastly, we have the perpendicular transversal theorem. On a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. Let us try these examples. Use a protractor to determine the measure of each angle in the following figures. and determine which of the lines are perpendicular. For number 1, we have line A and line B. Line A intersects line B, forming angles 1 and angle 2. Now, using a protractor, let us first measure each angle. Let us first measure angle 1. I hope that you know how to use a protractor to measure an angle. We also have a video lesson on how to properly use a protractor to measure an angle. Now, how do we measure an angle using a protractor? First, place the midpoint of the protractor on the vertex of the angle. Then, line up one side of the angle with the zero line of the protractor where you see the number 0. And then, read the degrees where the other side crosses the number scale. Take time to read from the right set of numbers. As you can see, a protractor has two sets of numbers. One set goes from 0 to 180, the other set from 180 to 0. Which one you read depends on how you place the protractor. Place it so that one side of the angle lines up with one of the zeros. So for this example, we will start counting the degrees from 0 to 90. Therefore, the measure of angle 1 is equal to 90 degrees. Now let us measure the other angle, angle 2. Again, to measure angle 2, we have to place the midpoint of the protractor on the vertex of the angle. Then line up one side of the angle with the zero line of the protractor. So for this, counting again from 0 degrees, we have the measure of angle 2, which is also equal to 90 degrees. Since the measure of angle 1 and the measure of angle 2 are both 90 degrees, hence angle A and angle B are perpendicular, since they form angles which measures 90 degrees or right angles. Next, let us proceed to example number 2. For example number 2, we have line C and line D. Let us first measure line A. Again, place the midpoint of the protractor at the vertex of the angle. We have the measure of angle A from 0 degrees up to 90 degrees. Therefore, the measure of angle A measures 90 degrees. Now, let us measure angle B. Again, let us count the measure of angle B starting from 0 degrees up to its second side, which is up to 90 degrees. Therefore, the measure of angle B is equal to 90 degrees also. For this example, since angle A is equal to 90 degrees as well as angle B is also equal to 90 degrees, hence line C is perpendicular to line D. Determining which of the lines are perpendicular is very easy since we just have to find the measure of the angle formed, and if the angle formed is a right angle, then the two lines are perpendicular. And for our third example, we have line E, line G, and line F. For example number 3, let us first get the measure of angle X. Let us first measure angle X, starting from this side. This will be our starting point from 0 degrees up to the other side of the angle. We now have the measure of angle X, which is 50 degrees. Again, the measure of angle X is equal to 50 degrees. Next, let us find the measure of angle Y. For this one, let us adjust or rotate the protractor to align one leg of the angle with the baseline.
Let us maintain the vertex of the angle in the origin and gently rotate the protractor so that one of the legs of the angle falls on the baseline of the protractor or the 0 degrees. Be careful which angle you read using the protractor. Let's start with the 0 degrees, the first leg from the base up to the second leg of the angle Y. So from 0 degrees up to the second leg of angle Y measures 40 degrees. Since the measure of angle X and the measure of angle Y were determined using the protractor, and adding these two gives us the result 90 degrees, therefore, we can say that line E is perpendicular to line G. I hope that you are now ready to answer the exercises given in this episode. Expectedly, the activities aim to intensify the application of the different concepts you have learned. For your activity, answer the following. Name the postulate or theorem that allows you to conclude that line A is parallel to line B. Write your answers on your notebook and then send it to your math teacher. And for your quiz, that is all for now. I hope you learned and enjoyed our lesson for today. Again, this is Teacher Nancy, your teacher for Math 8. Have a nice day, be safe, and God bless us all.